infinite darkness between the stars, the universe stirs with secrets older than time itself. Dust drifts, collides, and coalesces. Atoms join in silent unions, forming molecules that will one day become rock, water, and perhaps life. Light travels across unimaginable distances, carrying whispers of creation from distant suns. Somewhere, many light years away, a star has awakened, young and brilliant, surrounded by a halo of gas and dust, a cosmic womb. And within that womb, a world is taking shape. For billions of years, stars have given birth to planets, yet humanity has never witnessed such moments directly. Until now, we could only infer, imagine, or theorize. Gaps in dusty rings hinted at the presence of hidden worlds, while subtle wobbles in starlight suggested invisible sculptors at work. But theory and suggestion are not proof. To see a planet as it forms requires patience, ingenuity, and instruments capable of piercing the blinding glow of a star while revealing the faintest traces of life emerging from dust. A distant sun, known as wISPIT 2, became the focus of such a search. Astronomers suspected that within its surrounding disk, a young world might be growing, and after countless hours of observation, a single point of light emerged from the shadows, faint, crimson, but unmistakable. A baby planet had revealed itself in its very first moments of existence, feeding on the gas of its parent star. Humanity had captured its first direct image of a forming world, a glimpse into a process that usually takes millions of years, hidden from any observer. This world, named wISPIT 2b, is a giant, 5 times the mass of Jupiter, and yet it is only a few million years old. It exists in a delicate balance, nestled within the gap of a vast disk that stretches billions of kilometers across. The discovery challenges our understanding of planetary formation. How can a planet so massive form so quickly? How does it carve such a perfect path through the chaotic environment of gas and dust? These questions reach beyond curiosity. They touch the very heart of how we understand our own origins. Long before Earth coalesced, before oceans glimmered under the light of our sun, countless worlds were being forged in disks like this one. Particles collided, merged, and fractured, slowly building into the planets we now study. Each collision released heat, energy, and light, shaping the emerging world. Magnetic fields ignited, storms raged across molten surfaces, and matter continued to fall onto the growing cores. It was chaos and order intertwined, violence and creation inseparable. And yet even in this turmoil, a pattern emerges, the universal rhythm of planetary formation. Humans, for all our ingenuity, are mere observers in this cosmic dance. Yet through ingenuity, we have built instruments capable of extraordinary perception. The Magellan Telescope, equipped with the MAGO-X adaptive optics system, allows us to pierce the atmosphere and see distant worlds with unparalleled clarity. Its hydrogen alpha filter detects the faint crimson glow emitted as hydrogen gas falls onto a forming planet, revealing its presence. Infrared observations from other telescopes confirmed the discovery, providing independent verification that wISPIT 2b is indeed real. The universe speaks in photons. Each photon from wISPIT 2b carries a story from millions of years ago. When it reaches Earth, it tells us, I exist, I am forming, I am alive in my own way. And as we interpret these messages, we begin to understand the process of creation as it unfolds, one particle, one photon, one collision at a time. Yet even as we celebrate, questions multiply. Is wISPIT 2b alone? Observations hint at the presence of another faint planet in the disk, a sibling hidden in the shadows, waiting to reveal itself. If confirmed, this system will tell us not only about individual planets, but about the orchestration of planetary families, the dynamics of gravitational interactions, and the formation of stable, harmonious systems like our own. In witnessing wISPIT 2b, we confront the vastness of time. We see a world as it was, not as it is. Light takes hundreds of years to reach us, carrying the imprint of ancient processes. Yet this distance does not diminish the significance of what we see. On the contrary, it connects us to the cosmos, reminding us that every atom in our bodies was once part of such a dance, part of the same universal workshop that creates worlds. The discovery of wISPIT 2b is more than a scientific milestone, it is a philosophical revelation. We see that creation never stops, that the universe continues to forge planets, moons, and perhaps life, even in places far beyond our reach. Each newborn world is a testament to the persistence of matter, energy, and the fundamental forces that sculpt reality. And in observing them, we glimpse our own beginnings, reflected in the glow of a distant, crimson infant. As humanity continues to build more powerful telescopes, we will watch more worlds emerge. James Webb, Roman, and the extremely large telescope will reveal details we cannot yet imagine. The chemical fingerprints of planets, the atmospheres forming around distant worlds, the potential for oceans and moons. Each observation will expand our understanding, revealing the processes that shape not only distant systems, but our own solar system billions of years ago. wISPIT-2b reminds us of both our fragility and our significance. We are small, yet we possess the curiosity and ingenuity to reach across light years and witness the birth of a planet. We are transient, yet we bear witness to processes that endure for millions of years. Through observation, we become part of the story we seek to understand. In the glowing red light of a newborn planet, we see chaos, order, violence, and creation intertwined. We see the promise of worlds yet to stabilize, of moons yet to form, of atmospheres that may one day harbor life. And in this promise, we find a reflection of our own journey, from dust to planet, from chaos to consciousness, from the first collisions in the protoplanetary disk to the emergence of human curiosity. The universe continues its work. Dust clouds swirl, particles collide, and photons race across light years to carry the message of creation. Planets like wISPIT 2b will continue to grow, migrate, and evolve. Some will be destroyed, others will stabilize, and perhaps some will nurture life. And humanity, though small and fleeting, will continue to observe, measure, and wonder. Through our instruments, through our understanding, we become part of the cosmos observing itself. Every photon, every data point, every carefully measured spectrum is a conversation across time and space. And as long as we look, as long as we reach outward with questions and curiosity, the universe will answer, revealing its secrets, its beauty, and the eternal process of creation. As wISPIT 2b spins within its dusty cradle, we begin to understand the forces shaping its destiny. Gravity is both sculptor and master. It pulls, tugs, and twists the surrounding gas and dust, forming spiral waves within the disk. These waves funnel material onto the growing planet, feeding its core and fueling its fiery storms. In a few million years, this young giant will have swept its orbit clean, becoming a dominant presence in its solar system. But planets do not form in isolation. Every disk is a complex ecosystem, a gravitational ballet where multiple worlds may emerge simultaneously. Scientists now speculate that wISPIT-2b may have companions, smaller or more distant planets, hidden in the dim edges of the disk. Their gravity can warp the disk, forming gaps, rings, or spiral arms. Observing these subtle features is like reading the handwriting of the cosmos, deciphering clues left by worlds that cannot yet be seen. To capture these details, astronomers rely on instruments of staggering precision. Adaptive optics correct for the atmosphere's turbulent distortion. Filters isolate the faint glow of hydrogen or other elements. Infrared detectors sense heat invisible to the human eye. Each observation is painstaking, often requiring dozens of nights of telescope time. meticulous calibration, and mountains of data analysis. Yet the payoff is extraordinary, a window into creation itself.
wISPIT 2b offers more than a glimpse of planetary birth. It challenges our theories. How does a massive gas giant form so rapidly? Standard models suggest that planets of this size take tens of millions of years to reach full mass. Yet wISPIT 2b is already 5 times the mass of Jupiter after only a few million years. Could this indicate an alternative formation pathway? Perhaps the disk is unusually dense, or instabilities accelerate the collapse of gas onto the core. Each possibility pushes astronomers to rethink what they thought they knew about the physics of planetary formation. Beyond science, the discovery inspires wonder. To witness a planet forming is to witness time itself compressed into a single moment of understanding. Light from wISPIT 2b has traveled for hundreds of years, crossing vast interstellar distances. When it reaches our telescopes, we are looking back into history, seeing the planet as it was long before our own species walked the Earth. Yet despite this temporal gap, the universe communicates with us through photons, carrying the imprint of creation across the void. There is a profound humility in this realization. The atoms that make up wISPIT 2b, its core, its atmosphere, its faint glow, are the same fundamental building blocks that exist in our own world. Hydrogen, helium, carbon, oxygen, these elements have been recycled through countless generations of stars and planets. In studying a distant newborn world, we are, in a sense, studying ourselves, our origins written in cosmic script. The methods used to detect wISPIT 2b are as fascinating as the discovery itself. Scientists employed a combination of direct imaging and spectral analysis. Direct imaging isolates the faint light of the planet from the overwhelming glare of its star. Spectroscopy breaks that light into its component wavelengths, revealing chemical fingerprints, temperatures, and dynamics. Together, these techniques allow astronomers to map not just the position of a planet, but its ongoing growth, its interaction with the surrounding disk, and even hints of its internal structure. wISPIT 2b is a laboratory for understanding planetary physics. By measuring the rate of gas accretion, astronomers can estimate how quickly the planet is gaining mass. By observing the disk's structure, they can infer the presence of additional planets or gravitational instabilities. By tracking the planet's motion, they can model its orbit and predict how the system will evolve over millions of years. Each photon captured is a data point in a story billions of years in the making. Yet the planet is also a narrative of resilience and chance. A slight variation in the disk's density, a minor gravitational perturbation, or a fleeting collision could alter the trajectory of the planet's growth. The universe is a vast experiment in probability, where only some worlds survive, only some reach stability, and only some eventually host environments capable of supporting life. wISPIT 2b exists because conditions aligned perfectly, a cosmic lottery played out in a faraway corner of the galaxy. Observing the disk also teaches us about the chemical environment of planet formation. Molecules like water, carbon monoxide, and methane are detected within the ring. These compounds are essential for understanding how atmospheres and potential oceans might develop. Though wISPIT 2b is a gas giant, the surrounding disk contains the raw materials for rocky planets that could eventually form closer to the star, perhaps in regions where temperatures allow water to condense into liquid. The discovery resonates far beyond academia. It captures the imagination of anyone who has looked at the night sky and wondered what worlds might exist beyond our own. It reminds us that creation is continuous, that planets are forming right now, light years away, in ways both familiar and alien. It invites a sense of connection, a realization that the universe is not a static backdrop, but an active, ongoing process in which we are privileged witnesses.
Moreover, it challenges our understanding of time and scale. Human history spans mere thousands of years, yet planetary formation occurs over millions. The photons reaching our instruments carry stories of processes that began long before our civilization and will continue long after. In this perspective, we are both insignificant and significant, small in scale, yet capable of perceiving and recording events that span cosmic epochs. wISPIT 2b also exemplifies collaboration, ingenuity, and perseverance. Multiple observatories, international teams, and decades of technological development converged to make this discovery possible. From engineers designing adaptive optic systems to astronomers calculating orbital dynamics, from software developers processing massive data sets to theorists interpreting the results, this achievement reflects the cumulative effort of human curiosity and creativity. Yet, amid the complexity, the planet itself is simple. Matter obeying the laws of physics, responding to gravity, radiation, and motion. It is both mundane and miraculous. It is a young world, formed from the same elements that pervade the universe, yet unique in its circumstances, location, and trajectory. Observing it allows us to reflect not only on the mechanics of planetary formation, but on the profound beauty of the cosmos, the interplay of chance and law, chaos and order. As wISPIT 2b continues to grow, it shapes its disk, interacts with potential siblings, and gradually settles into an orbit that may last billions of years. This process, invisible to the naked eye, is now captured through human ingenuity, offering a window into the formative stages of planetary systems throughout the galaxy. Each observation informs models, guides future searches, and expands the horizon of what we consider possible. In observing wISPIT 2b, we confront the universe's vastness and our own fleeting existence. We are here for a moment, yet we witness processes that endure for millions of years. We are transient observers in an eternal cosmos, capable of perceiving and understanding events far beyond our own lifespan. And in doing so, we are reminded that creation is continuous, relentless, and awe-inspiring. As wISPIT 2b's disk comes into focus, a remarkable picture emerges, a dynamic, living system of gas, dust, and gravity. Spiral waves ripple through the disk, revealing the invisible hand of the forming planet. These waves are not merely aesthetic patterns, they are signatures of interaction, fingerprints left by the planet as it carves a path through its environment. Each ripple tells a story of collisions, migrations, and the delicate balance that allows a world to survive in the chaos of formation. wISPIT 2b is more than a planet. It is a messenger. Its mass, its orbit, its interaction with the surrounding disk all provide insight into the laws that govern planetary formation. Astronomers measure its movement with exquisite precision, tracking subtle shifts in position and velocity. These observations reveal how the planet gathers mass, how it influences nearby gas, and how the potential for additional planets within the system may be orchestrated by gravity. The disk itself is a chemical laboratory. Within the swirling clouds of hydrogen, helium, and heavier elements, molecules like water, methane, and carbon monoxide dance. These molecules, frozen in dust grains or glowing faintly under the star's radiation, are the ingredients for planetary atmospheres. By studying their distribution, scientists can speculate not only on the growth of gas giants, but also on the potential for rocky planets forming closer to the star, planets that may one day hold oceans, continents, or even life.
Yet the story of wISPIT 2b is also a story of chance. Planetary formation is not a deterministic process. A slight perturbation in the disk, a stray collision, or a subtle instability can dramatically alter the trajectory of a planet. Some worlds are ejected, others collide, while a few survive to settle into stable orbits. wISPIT 2b exists because conditions aligned precisely, a cosmic lottery that favors survival for now. Observing this newborn world also teaches us about the timescales of creation. Human history is brief, mere thousands of years, yet wISPIT 2b is millions of years old. Light reaching our instruments today began its journey long before humans walked the Earth. In a single photon, time collapses, allowing us to witness events that span epochs. This perspective is humbling, reminding us that we are observers of an ancient and ongoing process, participants in a story far larger than our own. Scientific discovery is not instantaneous. Capturing wISPIT 2b required years of preparation, collaboration, and innovation. Telescopes had to be precisely calibrated, instruments tested and retested, and observations repeated to confirm the planet's existence. Data streams had to be cleaned, processed, and interpreted. Every pixel mattered, every photon carried information. And when all the evidence aligned, the universe revealed one of its best-kept secrets: the birth of a planet in real time. Beyond the data, there is wonder. The moment of discovery carries a profound emotional resonance. To know that a planet is forming light years away, unseen by human eyes until now, is to feel the vastness of the cosmos and our smallness within it. Yet it is also to feel connected, to recognize that the same physical laws that sculpt wISPIT 2b shaped our own solar system and continue to shape countless others across the galaxy. This connection invites reflection. Every atom on Earth, every drop of water, every grain of sand was once part of a cosmic dance similar to the one unfolding around wISPIT 2. In observing distant worlds, we are, in a sense, observing our own origins. We are reminded that creation is ongoing, that the universe never pauses, and that life, in all its forms, is a product of processes both violent and beautiful. As the planet continues to accrete material, hot gas spirals onto its surface, generating shock waves that ripple through the surrounding disk. The ring of dust and gas responds, warping and forming subtle asymmetries that hint at hidden companions. Each observation adds to a growing map of the system's structure, revealing not just one planet, but the dynamics of a young planetary family. The implications are profound. wISPIT 2b challenges models of planetary formation, suggesting that giant planets can emerge more rapidly than previously thought. Its existence prompts questions about how common such systems might be in the galaxy. How many planets are forming right now unseen across the Milky Way? How many planets will survive to maturity, and how many will meet their end in cosmic chaos? Each discovery reshapes our understanding of planetary evolution, expanding the boundaries of what we consider possible. Observing wISPIT 2b is also an exercise in patience and perseverance. The light is faint, the signals subtle, and the process is slow. Months of observation may reveal only incremental changes, yet those incremental insights accumulate into a comprehensive understanding of planetary formation. Science, like the universe itself, unfolds over vast timescales, demanding persistence, curiosity, and dedication for those who seek to witness its truths. Through this lens, humanity's achievements feel extraordinary. We are small, transient beings on a fragile planet, yet we have built instruments capable of detecting the faint glow of a planet forming hundreds of light years away. We translate photons into data, data into understanding, and understanding into wonder. And in doing so, we become part of the universe's story, observers, interpreters, participants in the cosmic process of creation. wISPIT 2b is both young and ancient. Its formation is recent on cosmic timescales, yet the light reaching Earth has traveled hundreds of years to tell us its story. This duality of being newly formed yet observed long after its birth underscores the nature of astronomy itself, a science of time travel, perception, and connection. By observing distant worlds, we bridge epochs, linking our fleeting existence to the enduring processes of the cosmos. As telescopes become more powerful, the story of wISPIT 2b is only the beginning. Future instruments will probe chemical compositions, detect atmospheric signatures, and perhaps even glimpse the formation of moons or rings. Each new observation will add detail to the narrative, revealing the intricacies of planetary birth, evolution, and interaction within the disk. Humanity's understanding of creation will deepen, and with it our sense of awe and humility before the universe. The journey of wISPIT 2b also reminds us of the fragility and resilience inherent in planetary systems. Minor disturbances can alter destinies, yet some worlds endure, stabilizing over millions of years. Observing these processes offers lessons beyond astronomy. The universe balances chaos and order, destruction and creation, chance and inevitability. In this balance lies the potential for life, the conditions for planets like Earth to emerge, and the continuity of cosmic processes that define the history of the galaxy.
wISPIT 2b, in its infancy, embodies these truths. It is chaos and order intertwined, fire and dust entwined, instability and potential entwined.
By studying it, we learn not only about the mechanics of planet formation, but also about the persistence of life, the constancy of physical laws, and the vast, ongoing story of creation that stretches across time and space. As wISPIT 2b continues its delicate dance within the dusty ring, we are reminded that creation is ongoing, relentless, and profoundly beautiful. The universe does not pause. Stars continue to ignite, gas clouds collapse, planets form, and countless worlds evolve beyond our sight. Every newborn planet, like wISPIT 2b, carries within it the story of its star, the history of its disk, and the possibilities of its future. The planet's orbit is more than a path, it is a narrative of survival. Every interaction with the disk, every gravitational tug, every subtle disturbance shapes the trajectory of its life. A slight change in momentum could result in collisions, ejections, or dramatic migrations. Yet wISPIT 2b persists. It is resilient, a testament to the forces that govern the cosmos and to the delicate balance required for planetary systems to endure. Our ability to witness this process underscores the extraordinary nature of human observation. We live on a planet that once formed in similar circumstances, yet now we peer across the galaxy and see another world in its infancy. The same physics, the same chemistry, the same cosmic rules that forged Earth are at work here, billions of kilometers away. In this reflection, we find a connection, a bridge across time and space, linking our origins to distant, unseen phenomena. Beyond the mechanics of formation lies the deeper significance, the story of life, of potential, of possibility. While wISPIT 2b is a gas giant, its presence influences the surrounding disk, shaping the conditions for smaller planets, moons, and perhaps habitable environments. It is a guardian of sorts, a sculptor of potential worlds yet to come. Observing it allows us to glimpse the architecture of planetary systems, the interplay of matter and energy that might one day give rise to conditions suitable for life. The discovery also teaches patience and humility. The light we see today represents events that occurred hundreds of years ago. The planet has already moved from the position we observe, continuing its formation, accretion, and migration. We witness history in motion, a universe operating on scales far beyond human comprehension. Yet despite this temporal distance, we can understand, interpret, and marvel at the processes unfolding light years away. wISPIT 2b is not merely a scientific object, it is a narrative of cosmic persistence. Every photon reaching our telescopes is a message from the universe, a story of matter and energy following the fundamental laws that shape reality. Each observation is a conversation across time, a dialogue between human curiosity and the cosmos itself. And in that conversation, we find awe, inspiration, and a profound sense of place within the universe. As we consider the planet's future, we realize that wISPIT 2b will continue to evolve. Its orbit may shift, its atmosphere may cool, and interactions with other bodies may sculpt its destiny further. The disk itself will dissipate, leaving behind a mature system of worlds, each unique, each shaped by the intricate forces of physics and chance. Observing these stages provides a roadmap to understanding not only the life cycle of planets, but also the evolution of planetary systems across the galaxy. The implications extend even further. wISPIT 2b challenges our assumptions about how quickly giant planets can form, and how they influence their environments. It inspires future missions, encourages the development of more sophisticated instruments, and reminds us that every answer in astronomy often leads to new questions. In this sense, discovery is never complete. It is an ongoing dialogue, a continuous pursuit of knowledge that stretches across generations. Beyond the science lies the profound human experience of wonder. To gaze upon a newborn world is to confront our own beginnings. It is to recognize that every atom in our bodies was once part of a cosmic process similar to what we now observe. Earth itself was once dust spiraling around a young sun, colliding, merging, forming a stable world. wISPIT 2b allows us to witness that process anew, providing a mirror through which we see both the universe and ourselves.
In a broader perspective, this discovery reminds us of the resilience and creativity of nature. Chaos and order coexist. Destruction and creation are inseparable, and probability shapes outcomes across unimaginable scales. In observing wISPIT 2b, we see these forces at work, sculpting a planet, shaping a system, and perhaps one day influencing the conditions for life elsewhere. The universe communicates in subtle ways. The light from wISPIT 2b, traveling across hundreds of light years, carries information about its formation, composition, and environment. By interpreting this light, humans participate in a dialogue that transcends time and space. We are both observers and interpreters, bridging the gap between the cosmic processes of creation and our own understanding. wISPIT 2b's story is a reminder that creation never ceases. The universe is an eternal workshop, forging worlds, stars, and perhaps life itself. Each planet, each moon, each disk of dust contributes to the ongoing narrative of existence. And in observing these processes, humanity becomes part of that narrative, bearing witness to the beauty, complexity, and resilience of the cosmos. We also learn the importance of perspective. While we are small and our lifespan brief, we have the capacity to comprehend and appreciate processes that unfold over millions of years. We can measure, interpret, and reflect upon phenomena far beyond our own experience, connecting with the universe in ways that are both humbling and empowering. The journey of wISPIT 2b is both scientific and philosophical. It teaches us about planetary formation, yes, but it also teaches us about continuity, connection, and the interplay between chaos and order. It invites reflection on our own origins, our place in the cosmos, and the possibilities that lie ahead for understanding and exploration. As telescopes grow more advanced and observations more detailed, humanity will continue to witness the birth of planets, moons, and planetary systems. Each new discovery will expand our knowledge, deepen our appreciation for the universe, and inspire generations to come. In this ongoing pursuit, wISPIT 2b stands as a testament to curiosity, ingenuity, and the enduring drive to explore the cosmos. Ultimately, the story of wISPIT 2b is a story of connection between matter and energy, past and present, observer and observed. It is a reminder that creation is eternal, that the universe continues its work, and that humanity, though small, has the privilege of witnessing and understanding it. The planet spins within its disk, growing, interacting, and evolving. Its light reaches us across space and time, telling a story older than civilization itself. And as we gaze upon that distant glow, we realize that we are not mere spectators. We are participants in the universe's ongoing drama, witnesses to the formation of worlds, and inheritors of the knowledge that allows us to perceive the cosmos in all its grandeur. Creation continues, relentless and beautiful. Worlds form, stars shine, and life may yet emerge on distant planets shaped by forces we are only beginning to understand. And we, on our small blue world, watch, learn, and marvel, forever connected to the processes that gave birth to us and to countless other worlds beyond our sight. wISPIT 2b reminds us that the universe is alive, not in the sense of consciousness, but in the ceaseless dance of matter, energy, and time. Every newborn planet is a testament to this ongoing process, a signal that creation does not stop, that the universe remains active, vibrant, and full of possibility. And in this realization, we find awe, inspiration, and a deep sense of belonging. We are here to witness, to understand,
and to marvel. The universe continues to write its story in light, dust, and motion, and we are privileged to read it, even if only through the faint glow of a distant, newborn world. wISPIT 2b, in its infancy, carries the memory of creation, the promise of potential, and the testimony of universal laws. It is chaos and order entwined, simplicity and complexity intertwined, a newborn giant rising in a cosmic nursery. And as we observe, we become part of the story, part of the universe witnessing itself, part of the ongoing process of wonder, discovery, and awe. The universe is still making worlds, and we are here to witness it.